My name is Steven Aquino.
Good day, I'm Euleen Aranda.
Hello, my name is Godwin Broas.
Hi, my name is Gabriel Ayao, Group 2 that will present what is intellectual revolution all about. Before going on, the Johannes Kepler theory. Let us start where it started. The western part of the world believes that Earth was the center of the universe. It has sun, stars, and planets, and all of this is just a belief. So Nicholas Copernicus decided to start putting science in the center of the solar system that follows by Johannes Kepler. Many people agree, but the Catholic Church did not because of their own beliefs. So let us now proceed with Johannes Kepler theory. Johannes Kepler theory was led to represent astronomers of the scientific revolution, known for formulating planetary motion laws. Kepler laws of the planetary motion are all about the movement of the planets in the solar system and how it works. Kepler also claimed the gravity was caused by two bodies rather than one, and the moon was the cause of the moving tides on the earth. Now, we go to the Kepler's three laws of planetary motion. The first law is that each planet's orbit about the sun is an ellipse. It means that the sun is at one focus. The second is the imaginary line joining the planets and the sun sweep equal space areas during the time intervals as the planet orbits. That means the planets do not have constant speed along their orbits. The third one is the squares of the planet's orbital period are directly proportional to cubes of the semi-principal axis of their orbits. That means the sun increases rapidly with the radius of its orbit.
Kepler. Johannes Kepler is born 27th December 1571 and died 15 November 1630. Was a German mathematician, astronomer, astrologer, and natural philosopher. He is a key figure in the 7th century scientific revolution, best known for his laws of planetary motion and his books Astronomia Nova, Harmonies Mundi, and Epitanomy Astronomiae Copernicae. These works also provided one of the foundation for Newton's theory of universal gravitation. Kepler was a mathematics teacher at the seminary school in Graz, where he became an associate of Prince Hans Ulrich von Regenberg. And later, he became an assistant to the astronomer Tycho Brahe in Prague, and eventually the imperial mathematician to Emperor Rudolf II and his two successors, Matthias and Ferdinand II. Kepler lived in an era when there was no clear distinction between astronomy and astrology, but there was a strong division between astronomy. Astronomy is a branch of mathematics within the liberal arts, and physics is a branch of natural philosophy. Kepler described his new astronomy as celestial physics as an excursion into Aristotelian metaphysics. So what makes Kepler a key figure? He is the first to investigate the formation of pictures with a pinhole camera, first to explain the process of vision by refracting within the eye, first to formulate eyeglasses, designing for nearsightedness and farsightedness, first to derive logarithms, purely based on mathematics, independent of Napier's table published in 1614.
As said earlier, centuries ago, the Western world was all fixated on the idea that the Earth was the centerpiece of this universe. However, with the formulation of Kepler's three laws of planetary motion, people were able to identify how our universe works. How the Earth and the other planets orbit the Sun in an ellipse, how the planets move slower when they are farther from the Sun compared to when they are close to the Sun, and that the period for a planet to orbit the Sun increases rapidly due to the radius of its orbit. Even better, more ideas and concepts were introduced in the subject of astronomy. It is said that in 1666, Isaac Newton justified Kepler's law based on his three laws of physics and his law for gravitational forces. The only problem was that he could not formulate a solution as to why the actions at a distance obey an inverse square law. Fortunately, Albert Einstein and David Hilbert were able to develop the general relativity theory during the second decade of the 20th century, which actually solved the question about the inverse square law. Although it may be a small feature compared to the vastness of the whole outer space, this is a huge milestone for the subject of astronomy, as they have a reference to look upon, which is Kepler's three laws of planetary motion.
Now we will be moving over to the controversies that surrounded Kepler's intellectual revolution. As we are all aware of the conflict between science and religion, Kepler's theories were no exception to the tension. Kepler published the first public defense of the Copernican system in 1596. This was a risky position considering that Martin Luther, the Lutheran Church founder, scorned the theory when he first heard it in 1539. And even the Catholic Church declared such a position heretical in 1615, where they later subjected stargazer Galileo Galilei to house capture for his distribution regarding the matter. However, the capture might have had more to do with the way that he had offended the Pope. On NASA's JPL website, Dan Lewis, curator of the History of Science and Technology at the Huntington Library in San Marino, California, he said that the era in which Kepler lived was one of tremendous upheaval and change. In another statement, he mentioned that religious leaders were reluctant to relinquish their ideas about the heavens. Talk by astronomers of a sky filled with objects moving in non-circular orbits and other phenomena that went against an Earth-centric model threatened their beliefs. Kepler's intention was not to cause a stir in the church. Rather, astrophysicist Paul Sutter stated in a Space.com article, Expert Voices column, according to Sutter, Kepler said that since the Son of God was at the center of the Christian faith, the Sun ought to be at the center of the universe. Kepler's justification of the Copernican model was based on theological grounds and not physical or mathematical principles. In any case, as per Louis Kepler and his first spouse Barbara, made of code with which to compose letters to one another so their correspondence would not put them in danger of mistreatment.
Kepler is most recognized for formulating laws of planetary motion, but he also made other significant contributions to science. He was the first to discover that refraction is what causes vision in the eye, and the depth perception is only possible when two eyes are used. He made nearsighted and farsighted eyeglasses and demonstrated how a telescope worked. He went into detail about pictures and magnificent by understanding the properties of reflection, and that is one of the many good examples of how Kepler's contribution to science are practically applied today. Kepler claimed that gravity was caused by two bodies rather than one, as as such, the moon was the cause of the moon of tides on the earth. This information is a notable discovery since it has helped many and has even saved lives to prepare, especially before the occurrence of high tides. Kepler wrote that if the earth ceased to attract the waters of the sea would rise and flow into the moon. According to Michael Fowler, a physics professor at the University of Virginia, if the attractive force of the moon reaches down the earth, it follows that attractive force of the earth all the more extend to the moon and even farther. He also coined the term satellite to describe how the sun rotates. He attempts to use his understanding of Earth travel distance to calculate the distance to the stars.
And that is all for our presentation. We from the Group 2 thank you for watching.